Hey everybody, this is Larry. This is day 21st of the March Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's farm. Today is a rest day. Thursdays has been my rest days for a little bit. I need to figure out my training schedule, honestly. But there is a schedule. It's just, I don't know how I feel about it. I'm not recovering enough. I think I'm not eating well enough or sleeping well enough. But, I can fix that. I just need to actually do it. Anyway, let's take a look at today's farm. I don't have that much of an update there. I was eating candy earlier. Now my mouth is full of candy. Hang on. Alright, let's take a look at today's farm. We have 2115. Find all possible recipes from given surprise. You have information about n different recipes. You're given a string array recipes and a 2D string array ingredients. The ith recipe has the same name, or has the name recipe sub I, and you create it if you have all the needed ingredients from ingredients sub I. A recipe can also be an ingredient for other recipes. Ingredients sub I can be in recipe. Okay. Oh, ingredients sub I may contain a string that is in recipes. Okay. You're given a string array surprise containing all the ingredients that you initially have. You have infinite supply of all of them. Return a list of the ingredients you can create. You may return the answer in any order. Note that two recipes may contain each other in the ingredient. Okay. So I mean, right off, I have to be really quick. Just want to confirm things, but right off the bat, I would say my thought is just what's it called? Topological sort, right? You don't even have to sort them. It's just like a dependency graph thing, right? Like the way that I always think about these is like thinking about classes. In terms of like, okay, well, I have read well, in classes term is like I took physics 101, so that means I could take physics 102, and maybe physics 201 requires calculus. And so if I want to take physics 201, I would have to, and then you kind of go up the graph or down the graph, depending how you want to say it, right? And this is basically the same idea, I suppose. So you start with surprise and go. You have these. If you have yeast and bread, and because you have a limited number of these, that means that you're able to make bread, right? So I think this one, after you get the algorithm, it is just an implementation thing and just about transforming in a good place, right? I think the two directions that you can go from. One is that given that you could just check for each recipe, can you make it, right? The other is given all these supplies, what recipes can you make? Of course, one is kind of more top down, the other is kind of bottom up, if you will. And either one is fine, I think. I don't know that there's that much difference between them. I mean, of course, there may be some yeah, there may be some minor nuance, but I think that's fine. I think one thing that I'm trying to think is, what does a circular dependency mean, right? Meaning that a recipe may have, I think you mentioned it somewhere, right? Two recipes may contain each other, right? Like if A contains B and B contains A, do you need to, I guess you just need the first one, maybe? But it's a really awkward phrasing, I think. I don't know, do you get, can recipe be in surprise? Okay, so it is unique. So, okay, so that's a little bit different. Because you can imagine that, let's say, I don't know, A requires B and B requires A. But if you're given A to start as a supply, then the cycle doesn't matter. Not that it doesn't matter, but you're still able to just get it, right? So in that sense, the cycles are not as whatever. But yeah, I think that's sufficient. I think we can just do a recipe thing, right? So here, maybe the way that we'll look it up is just have um maybe I'll write them as dependencies. And the only thing that's different about this format is just I want it to be a lookup. That's all. And you could also normalize it one more step by convert it to a number, but I don't think it's necessary. Maybe I'm wrong, and if I am, then I can change it. But for now, yeah, not going to. But yeah. So let's put them together. It's very awkward, the naming, but ingredients because it's like because it's not ingredients, it's more like an ingredients list, and you have ingredients for each one. I think that's why it's a little bit awkward. So okay, let's convert this to something like this, right? And then this is just me doing yeah, just doing a lookup thing. So we're not really doing anything that fancy on the processing side. Okay, and then now, maybe we start with enter for recipe in recipes. If can recipe, then enter that append recipe, right? And that's it, right? Of course, that's it is doing a lot of work because we have to actually implement this, right? So can we do this, right? And here we can actually even cache for yeah, oops, for memorization. I'm not gonna go over memorization real quick. I mean, for this one, I'm not going to go over it. I don't think. Maybe I will, but it's just that for every recipe, we want to see if we can make it from surprise, right? So see if we can make the and it's not a recipe. Yeah. The recipe from surprise, and yeah, and as a result, we can cache it. Maybe not. The circular dependency thing is a little bit awkward. I think we have to do the 3-color thing. Right. Yeah, so here we have maybe I always write this one differently because it doesn't come up enough times for me to, I don't know, write it consistently. But the idea is that, okay, before you visit it, it is going to be right? So yeah, so 3 colors, right? White, gray, and black. So the first time, if it's white, then you haven't visited yet, right? So yeah. If it's gray, that means that you visited, but it hasn't resolved yet. So that means that it's no. So okay, right? Oh, we also want to pre-process surprise into a set just to make things lookups a little bit easier, right? So surprise is also set. It's a little bit awkward as well. Let's just go to list. Maybe, I don't know. Right? And okay, and then now if the current recipe is in surprise, then we can return true. Pretty straightforward there. That's the base case. Otherwise, we have for ingredient in dependencies of recipe, we just go if we can go ingredient, then return false, and then return true. So this would be mostly be done if there are no cycles, right? But there are cycles, so we have to make some adjustments, right? Otherwise, this is just going to give me an infinite loop. Okay, that is surprising. Oh, probably because they don't actually have, even though they have this, it's probably just that there are no cycles here, right? I mean, like I said, otherwise it would have been done. So we can write something like, I don't know, is it these 3 things, right? we can this so bread requiring sandwich would be a no-no, right? So this would give you an infinite loop, right? Or recursion thing. I mean, yeah. So then here we can just, now we have to check the colors, right? The two things, one is, yeah, so colors is you go to right times I guess it's just a collection actually. Oh, I mean, we'll just use a lookup table. But so okay, so 3 colors, right if it doesn't exist, and then here we can just have some lazy nums for the other 2, right? And here it's if colors sub in if ingredient is in color, which means that's already not right, and colors of ingredient is gray, then that means that's not possible because there's a cycle of sorts, right? So return false, then otherwise do, right? I mean, if it's black, it's also, well, if it's black, then we should return the preset results, right? The cached results. So maybe we can have like we put the cache here, right? So maybe cache is equal to right? So if it is black, if ingredient, maybe I'll put this here. Okay, so if it's gray, that means that there's a cycle, so we return false. Otherwise, if colors ingredient is equal to black, if it's black, then we just want the cache's answer, and if it's black, that means that it's already in cache. So we want cache of ingredient, but we want it to be true false. So if it's false, then we return false. So that means that we write something like this, right? Because if it's true, we just keep going, right? Otherwise, so here we want to write and this is, so this is only if it's right, and if it's right, then we do a recursion, which is why we have to, okay, LSF, right? Otherwise, we put colors of recipe to gray, and here we set colors of recipe to black, and we also want to put the cache of black to, well, in this case it's true, but we shouldn't only cache if it's true, right? We have to do the other things. So yeah, so we have to maybe write something like, it's very awkward, I think, but it's okay, right? And here as well. Hope this is good. But yeah, looks okay, at least for this case. It honestly is very easy for me to make a mistake. I think this one I actually don't do a cache here, so we need to check here, right? So if color sub recipe is black, we can return cache of recipe. It reduces it from I think potentially n squared to n, but yeah. What does this say? Oh, I have to check that recipe is in colors. Yeah. That's why I debated writing this in a different way, but maybe we should. Maybe that's a little confusing. Yeah, maybe I'll write it this way. And then here I just do. I kind of was debating about it. I don't know if you remember me writing something like this, right? I was kind of debating it, but I was like, all right, fine. Right, so all right, let's give it a submit. I'm not 100% confident. There are a lot of, oh, well, I didn't click on submit, so definitely not confident. But if I click on submit, I'm not 100% confident, but, oh. Why, oh, it doesn't have dependency. Okay, so I didn't consider that. I usually don't write it this way, that's why, but, that is my silliness, I suppose, and this is on the third case, actually pretty bad. But and actually that should have been a very basic thing. But why does it return? Oh, it returns true if all these are satisfied. But if it's how can I tell that flower is I mean, I think the base case is a little bit off as the TLDR, but it's not clear to me that flower, like, I return true as a default if all these things are satisfied. Oh, I guess if all its ingredients are possible, or it doesn't have any more requirements. And flower, by definition, if I go recursively, it's not in supplies, but it's also not in ingredients. How do I know that flower is? I mean, I know that looking at here, we can say it, right? So this is actually a very legit wrong answer. How do I? Because even without cycle, this is the wrong answer, right? But how do I go? Okay, flower. Is it just that we don't have a recipe as well? Like, it's not clear to me from here necessarily that flower. Okay, so flower is obviously not in supplies, but it's also not in recipe. Is that good enough for it to be like return false? I don't know. We could try it though. Okay, so if recipe not in supplies and not and recipe not in or not in is not equal to, right? Oh no, it's not in. Sorry, and not in recipes. Go recipes or in dependencies. So if they're not in either, then we just return false, right? And we can cache it, but it's not that much of a big deal because it just does 2 more if statements. So I'm a little bit lazy. Yeah, let's try. Hopefully this is enough. Okay. So I guess that is a good enough thing. I mean, it's sometimes it feels a little ill-defined, but it doesn't mean that it's not good enough. It's just that, you know, it's not defined. Why does it put me at the end, but then like it just said 95%? I don't know, whatever. But yeah, this is gonna be linear time, right? We look at each node and each recipe once, or each ingredient once, even, right? But yeah, and we prevent the cycle with this 3-color system, which I don't implement enough clearly, but also probably fine. But yeah, otherwise it is sort of a topological sort, if not precisely so, but you know, approximately so. Yeah, that's all I have for this one. Let me know what you think. Thanks for watching. Let me know in the comments if you did it the other way from the supplies up. I'm curious. Probably looks roughly the same, right? I don't know. But thanks for watching, and yeah, stay good, stay healthy. To get good, man, maybe I need to good mental health. To good mental health. I'll see y'all later and take care. Bye bye.